Hey everyone, welcome back, and in this video we are going to talk about how we can install Docker in Gen or Ubuntu. So basically this is the official documentation, and here you can just use these commands. Okay, so whatever commands is given, you have to just execute one by one, and you will have the Docker ready in your system. So first we you need to uninstall any older version if you have. So just open up a terminal and run this script. Sorry, this command actually. So nothing I have here, and then you have to create a docker.sh. If you want to create, you can, and then below you will see you need to set up apt repository first. So just copy this all command and paste it here, and use swift colon wq. First you need to press wait just a minute. I will just clear everything again. Press I and then control shift V. Just next we have to install the Docker packages, so we will use this command. Okay, so we will do just Docker is running, do for me my time. Okay,
Hi, so you're a developer. Well, you think you're a developer. Nice. Building app developer's law. Any code that works perfectly on your machine will inevitably fail on everyone else's developer tools. What? Okay, so document and deployment and have it.
I like my
The actual meal. It's what gets made from the recipe. Now the cool part about containers is with one image, we can create multiple container instances. What? Now what does this mean? It means as long as you have the Docker image, you can create a container and run the code. You want proof? Here's me running a Docker image that contains Doom. Yeah, the entire game of Doom. To be fair, you can run Doom on almost anything, but this is what makes Docker amazing. It allows us to simplify the process of sharing code. You no longer have to do a tedious process like installing all these tools and making these configurations to run some code. All you need to do is run one Docker command and it does the rest for you.
Yeah, that makes sense.
I simplified this explanation a lot because a lot of you have a shorter attention span than a goldfish. So if you're a nerd and you actually want to learn more about Docker, I'm going to have links in the description if you want to do your own research. Or you can check out my free newsletter called Slackwork.com or click the link in the description and download Docker Desktop. It'll download Docker for you and it comes with a nice little GUI to manage your images and containers. But if you're feeling like a grown-up, it also comes with the Docker CLI so you can do everything in the terminal. Step 2, check if you have Docker. Open up your terminal and type docker -- version. If you see this, you have Docker installed. If you don't, then good luck, little bro. Figure it out. Step 3, set up Docker on your IDE of choice. I'm doing VS Code because I hate myself. Make sure to download the Docker extension on your IDE because it'll have language support and other goodies that'll make your life so much easier. Step 4, the Docker file. This is pretty important. Now, what's a Docker file? Remember our recipe analogy? This is literally where we write our recipe. Let's write one together. Here we have a simple Node server. Yeah, you heard me. Node. JavaScript. First, we're going to create the Docker file. And inside this file, we're going to write the steps and instructions to run the server. Now, in order to write the steps, you need to know the steps. So you need to understand how to run the server. But since we're using JavaScript, it's pretty easy. First, you get your code, then you go into the file or directory, download your dependencies, and then you run the server with the npm start command. Bada bing, bada boom. Easy peasy. Now that you understand how to run the server, all we have to do is write all that in our Docker file. What? So at the top of your Docker file, you're going to write from. And if you downloaded that Docker extension I told you to get, like the good boy you are, if you hover over it, you're going to get some nice documentation. Every Docker file starts with this command. Now we have to select a base image. And a base image is basically just our starting point. We can use the officially supported Node.js base image that comes with everything we need. So in our Docker file, we're going to write from node:22. All we have to do now is write the instructions to start the server. So underneath the from command, you're going to type workdir /app. Workdir stands stands for working directory. And this is underneath the from command, you're going to type workdir/app. Workdir stands for working directory. And this is basically us telling Docker, hey, start at this point. This is where our code's going to be. The next step is a very important step. So you better listen to this step. Usually in a node project, we get our code and then download our dependency. We could do that in Docker, but that's not the best way. Instead, what we'll actually do is we're going to download our dependencies first and then get our code. So we're going to write these commands. This first command copies our package files, and the second command, well, it should be pretty obvious. It installs our dependencies. Now, why are we doing this? Unlike you and me, Docker is actually pretty smart. It has this thing called layer caching. You can basically imagine every step that we write as a layer, and Docker looks at every layer individually. So for layer caching, it goes like this. Layer changed, do it again. Layer did not change, use cache. That's it. So the reason we do this for our dependencies is every time we change our code, it's not going to download the dependencies again. It's just going to use the cache. So it basically skips this step, which makes our builds way faster. Our next step now is to copy the code into the image. We do that with this command. Wow. Now this command copies everything, all our files and our folders into the Docker image. But this is a problem. Since we're copying everything, that also means we're copying our node modules. That's not good because this file is big, but not as big as your mom. We need a way to ignore that file. We can do that with a Docker ignore file. And inside that file, we're going to add the node modules folder and any other files you don't want in there. On to the next step. In our code, we have this port environment variable. We need to add this into our Docker file. We can do that with the env command. Now, since this environment variable is a port, we're also going to need this command. This basically tells Docker, hey, we're going to need this port. Now it's time for the last step, running the server. We do that with this command. Whoa. Why'd you do it like that? And why didn't you just use run npm start like you did for install? Good question, actually. The reason is because the run keyword happens when we're building the image, while the cmd keyword is what Docker uses to actually start the container. If we use the run keyword for this step, the container would never start. Anyways, enough yap. Our Docker file is complete. Start like you did for install. Good question, actually. The reason is because the run keyword happens when we're building the image, while the cmd keyword is what Docker uses to actually start the container. If we use the run keyword for this step, the container would never start. Anyways, enough yap. Our Docker file is complete. Step 5, building the image. We're gonna have to be grown-ups here and use our terminal. To build your image, we use the docker build command. So inside your terminal, you're gonna type docker build -t. T stands for tag, and it basically means give your image a name tag. Understand? So give your Docker image a name. You can name it whatever you want. The last thing we're gonna add is the path to our Docker file, which in our case is the current working directory. So all we have to do is type a period. Run this command, and you're gonna see Docker running all the steps we wrote in our Docker file. Step 6, running the container. We can do that with the docker run command. Make sure you write the name you gave your image.
Hey, what's that -p?
This -p is for port forwarding. You can do your own research for that, but for now, think of it as a bridge between our computer and our container. The number on the left is the port for our computer, and the number on the right is the port for the container. If you don't add this part, it's not gonna work. Go ahead, try it. I dare you. Run the command, and you're gonna see that your node server is now running. Congratulations, buddy. You know the basics of Docker. I'm proud of you. Step 7, debugging. Even though Docker makes it easier for us to share code, it doesn't stop us from building our containers wrong or from writing trash code. Luckily, debugging and checking any logs is pretty easy with Docker Desktop. So open up Docker Desktop and look at the container that's running. It should have a little green dot. Click the container and you can view any logs, you can execute any terminal commands, and you can see how the container's doing. Pretty simple. Now, if you think you're too good for a GUI, you can also do this in the terminal with the docker exec command. Step 8, Docker Scout. Now, if you notice, when you ran the docker run command, Docker gave you a recommendation to run this command, Docker Scout Quick View. Now, what's Docker Scout? It's a tool created by Docker that looks inside your Docker image and it generates a detailed report of all the packages that do this example. What if? Step number 9, Docker Compose and Docker Volumes. Let's be honest here. This node example was really simple. Nowadays, babies in the womb can do this example. What if we wanted to add a database? What if we wanted to add a front end? How do we add that with Docker? Now, you could combine all of them into one giant container, but I don't recommend that. A lot of people don't recommend that. Please don't do that. It's pretty stupid. Now, the way people usually do this is they separate each of these services and put them in their own containers. And this is called a multi-container application. What an obvious name, right? But this creates a brand new problem. Now that you have multiple containers, you have to run those containers separately and you have to find a way to connect them all together and manage them. This is a lot of work and a lot of areas could go wrong trying to manage these containers. Lucky for us, a lot of programmers are lazy, just like me, which is why we have this tool called Docker Compose. Docker Compose is pretty easy to understand. It basically tells all your containers how to work together to create the full application. Let me show you a quick example on how to use it. Let's pretend we added a database to our node server. So the first thing we're going to do is create a compose.yaml file. And inside that file, we're going to create an object called services. And inside that service object, we're going to be writing down keys that represent the containers we want to run. So in our case, our backend and our database. Since our backend is using a Docker file we created, we're going to use the build key, and the value value is going to be the location of our Docker file, which in our case is the current working directory. So it's going to be a period. And remember, our backend needs port forwarding. So we're going to add that in our configuration too. And now moving on to our brand new database container. What we're going to put inside of this one is the image key, because we're not using a Docker file for this database. Instead, what we're going to do is use a base image of the database we want to use, which for this example, I'll go with Postgres. Now our database also has some environment variables we have to add. So we can do that with the environment key. And underneath that, we just add all the information. Okay, we're almost done. I swear, I pinky promise. We just need to add one more thing, and that's a volume. Whenever we close our containers, we lose all the state and data. And our containers right now don't share data between each other. So we need to add a volume.
What is that?
All right, a volume is basically just a folder on our computer that Docker can access to save any data from our containers and to share that data with other containers. And it's pretty easy to create. Inside your Docker Compose file, you're gonna copy down this stuff. And this line right here says, hey Docker, create a volume called Postgres data. And the other one tells Docker, hey, we have this volume here. This is how you connect to it. Our Docker Compose file is now complete. All we have to do now is run this command in our terminal. Docker compose up. And Docker will find this configuration file and run all the containers together. And if you want to shut down your containers, then run this command, Docker compose down. And that's all you need to know about Docker Compose, because I'm too lazy to teach you anything else. Step 10, Docker build cloud. If you've noticed, building our containers takes a bit of time, even for this simple node server. Now imagine how long these containers take for a complex application. Apparently, based on this 2022 survey from Incredibuild, the average developer loses an hour just waiting on their Docker build. Docker realized this problem and recently created something to help reduce build times. They created Docker Build Cloud, and the main difference is it builds your containers using the cloud. Yeah, it's in the name. Now, in Docker's words, using the cloud allows your builds to be up to 39 times faster. Plus, if you're working with a team, you can share the same cache with them. So one person can build the image, and now everybody can use that same cache, which speeds everything up for everybody. So if you have a more complex project or have a Docker project that takes forever to build, you should probably check out Docker Build Cloud. I'm not going to show you how to do it because I don't have a complex project.
Step 11, always your way.
Cuy, pas awal-awal gue belajar coding, memang sangat banyak konfigurasi yang kalian bisa lakukan di Docker. Gue akan coba yang paling sederhananya aja, terlebih untuk proyekan sederhana yang udah dikembangin oleh adik gue dengan teknologi React.js, kayak gitu. Tapi sebelum lebih jauh, mungkin ada yang belum tahu Docker itu apa. Secara teori kalian bisa tanya ChatGPT supaya lebih lengkap lagi, lebih jelas lagi penjabarannya. Tapi di sini gue akan coba jelaskan secara manusiawi aja, sepemahaman yang ada di otak gue ya guys ya. Misalkan kalian punya sebuah aplikasi berjalan di atas React.js di laptop atau di PC Windows kalian. Terus kalian punya temen yang berjalan sistem operasinya di Linux atau di Mac OS. Nah, karena kita berjalan di sistem operasi yang berbeda, di mana teman lu itu running Linux atau Mac OS, kita PC-nya itu Windows, terkadang seperti yang ada di PC kita. Yang mana kontainer itulah yang akan di-running oleh teman kita di sistem operasi yang berbeda dengan database, koneksi database atau ada API-nya juga ya. Terus kita kirim misalkan proyekan React.js, mereka harus install dulu misalnya MySQL-nya, XMPP-nya atau apa yang kayak gitu-gitu. Dengan ke teman kita, dia nggak perlu install XMPP sama kayak kita, karena mungkin di Linux itu nggak ada XMPP. Dia pakainya WAM atau pakainya LAM. Nah, proyekan kita bisa di running dimanapun tanpa harus memikirkan. Ikutin tutorial ini. Caranya cukup sederhana. Tentu Windows fitur on off-nya kalian cari. Tinggal klik OK-nya. Kita install dan di sini muncul dua configuration, yaitu hasil downloadan Docker. Lama di sini kalian harus Docker update. Jadi buka aja lama, terkelar tinggal di kasus gua. Terus kalian tunggu aja sampai prosesnya React.js. Jadi seharusnya ini mudah, kita langsung saja masuk. Jamnya kita coba cek dulu Docker yang kita punya di PC desktop masing-masing. Kita coba buka punya ya, kita ketik Docker. Enggak, beginian sama kayak gue ya. Artinya ini Dockernya udah aktif, kita bisa mainin Docker file untuk kita coba build proyekan React.js adik gua ke dalam sebuah kontainer. Yang mana kita pakai bantuan Docker ya guys ya. Ini kita tinggal minimize aja kalau ini udah nyala. Cuekin yang ada di sini, ini adalah proyekan gue yang lainnya ya guys ya. Intinya nanti kalau kalian pertama kali buka Docker desktop itu di sini akan kosong seharusnya, dan di bagian image paling cuma ada satu image yang kayak beginian atau dua, atau code terlebih dahulu untuk proyekan React.js. Bikin Docker filenya dulu, karena feed ini running di secara default dia running di localhost 5173 kalau kita nyalain yandev kayak gini ya. Dia akan running di lokan bahwa kontainer yang kita punya itu JS kita bisa masukin sini dengan cara masukin server di bawah plugin. Ini bisa lu masukin kayak default, nilai defaultnya semua baca aja nih, on all address including LAN and public atau si feednya. Kalau sebelumnya kan 5173. Terus di sini kita bikin satu file yang namanya Docker Kerjakan React.js yang sintaks better docker file system sistem sintaks. Nah gue pakai yang ini. Sebenarnya bebas mau pakai yang mana ya, kalian coba download aja pokoknya yang ada docker filenya, download aja extensionnya biar lebih mudah. Tapi itu bukan wajib, jadi kalaupun kalian nggak download extension ya bisa-bisa aja. Cara pertama, kita bikin React.js ini running secara development di Docker filenya dengan cara kayak gini. Jadi di baris pertama itu kita masukin dulu base image. Untuk kita running React.js-nya itu kita based on image apa. Nah di sini gua akan pakai official Node.js versi 16. Jadi kalian ketikin aja node.2 kayak gini, 16 strip Alpine. Gua pakai Alpine ya. Jadi ini tuh kurang lebih apa ya, kayak macam anggaplah ya, tapi bukan ya, tapi ini anggaplah ini adalah sistem operasi atau kayak gimana jelasinnya. Ya ini adalah yang membungkus software kita gitulah kurang lebih, atau web app kita. Biar orang-orang juga sama nanti akan running di sini. Anggaplah ini tuh kayak Node.js yang kalian punya di PC. Nah, kayak gini. Tapi lu masukin ini ke dalam sini. Versinya terserah, mau kalian atur berapa juga terserah. Cuman biasanya kalau di Dockerfile gue pakai Alpine karena kenapa? Karena katanya gue belum pernah secara langsung jujur-jujuran aja ya tes performance yang Alpine dengan yang non Alpine kayak gitu. Tapi kebiasaan aja gue pakai Alpine karena itu works. Gitu aja simple ya. React.js-nya itu akan masuk ke dalam kontainer dir spasi ke workdir. JS-nya itu akan masuk ke dalam kontainer, masuk ke mana direktorinya? Masuk ke workdir namanya. Ketikin aja command-nya itu workdir spasi nama path-nya itu apa? Biasanya itu di /app kalau gua pribadi. Ya, ini tergantung terserah kalian, ini random, kalian parah bisa setting terserah kalian. Kita tinggal copy package.json yang ada di sini masuk ke dalam kontainer dengan cara apa? Copy. Nah, kayak gini. Sini kan muncul tuh 2 biji. Copy spasi source spasi destination. Source-nya itu dari mana? Nah, source-nya itu apa? Kayak gitu maksudnya. Yaitu si package.json kita mau masukin ke destination-nya itu yang mana? Destination-nya adalah kontainer kita, gitu. Source-nya adalah dari package.json. Kalian bisa masukin kayak gini, package.json seperti ini. Ke mana? Ke titik. Nah, titik ini artinya workdir kita ya. Bisa kalian masukin kayak gini juga bisa, cuman kan kita udah tentuin workdir-nya, jadi kita nggak perlu /app, bisa langsung titik, artinya direct langsung ke dalam workdir yang kita punya. Mau titik slash itu sama aja, tapi kalau bisa kecil kenapa harus panjang-panjang gitu kan, kalau bisa pendek maksudnya. Package.json dan juga package log.json. Nah, tapi kalau kita mau masukin package log.json itu kan kita mesti copy ini ke bawah, terus di sini harus spesifik kayak begini ya, capek. Nah, cara cepatnya adalah kita langsung aja di sininya package bintang titik JSON. Nah, jadi ini nggak perlu. Bintang artinya apapun setelah kata-kata package di dalam sebuah file .json ujungnya package.json. Atau kalau mau lebih enak lagi nggak usah pakai .json, ya udah gini aja package. Artinya semua akan masuk ke dalam workdir /app. Nah, gua yakin bahwa di React.js sebuah file atau folder dengan nama package itu cuman package strip. Tapi seharusnya kan nggak kayak gitu ya. Bisa kayak gini. npm install atau npm i gini juga bisa, sama aja ya guys ya. Artinya di dalam kontainer kita udah punya folder app, terus kita copy package.json dan package lognya ke dalam app di sini. Nah, kalau udah di copy ke app, kita install si package-nya di dalam app ya. Jadi nanti bakal kayak punya project kita kayak gini, akan ada node modulesnya di dalam si app sini. Betul? Ngerti maksud gua? Kayak lu copy React.js ke PC temen lu kayak gitu-gitu, yang mana temen lu cuma nginstal npm install doang tanpa harus lu copy node modulnya, karena ini adalah sebuah modul yang sangat banyak bejibun isinya ya guys ya. Kalau kalian lihat itu nggak mungkin untuk di copy paste kayak kayak gitu, kayak bercanda aja gitulah ya kalau di copy paste node modul. Jadi kita pakai npm install. Nah, di sini gua akan install gua akan bikin kontainer Dockerfile ini versi development mode ya, bukan versi production. Untuk yang versi production nanti kita akan bikin satu lagi. Jadi di tutorial yang awal ini gua bikin dulu yang versi development. So kita tinggal copy semuanya, semua source yang kita punya, Kalau ini kan cuman package kayak gini doang, dan kita install package dependencies yang kita punya di React.js-nya ke dalam kontainer. Sekarang kita copy semua source yang kita punya di dalam src, segala macam, public, semuanya itu masuk ke dalam kontainernya dengan cara copy spasi titik. Nah, kayak gini aja. Artinya, semua file folder yang kita milikin, JS-nya, CSS-nya, atau apapun itu masuk ke dalam kontainer kita, gitu ya guys ya. Titik itu source filenya, destination adalah si /app-nya. Oke? Kalau udah kayak gini, tinggal kita run aja command untuk menyalakan Node.js-nya. Karena di sini kita base image-nya adalah Node.js, jadi sini kita masukin cmd. Kalian bisa lihat di sini ada executable, ya guys. Executable untuk Node.js itu apa? Secara default di package JSON yang kita punya kalau kita running React.js dengan feed, ya di sini kan feed config ya, kita pakai feed. Itu ada di dev sini kalau untuk development, ya. Kayak yang tadi gua lakukan di sini yarn dev ini. Ini yarn dev kayak gini kan? Sama ya. Oke, sekarang runningnya udah di 3000 karena di config file kita udah listen ke 3000 ya guys ya. Jadinya kalau kita yarn dev di proyekan lokal yang punya adik gua, itu akan ngelisten ke localhost 3000 guys. Nah, sama pula dengan yang di Docker. Di sini kita tinggal masukin npm, run, dev. Artinya kita akan merunning proyekan yang kita punya setelah semua proyekannya tersetup di dalam kontainer. Package JSON-nya ada, dependensinya modulnya udah terinstall, source code kita punya udah masuk ke kontainer, kita running npm run dev di dalamnya. Kalau udah kayak gini, kita save aja Docker filenya. Dan ada satu hal lagi yang harus kita masukin di sini adalah namanya docker ignore. Bikin satu file di luar sini .docker ignore. Apa docker ignore? Ini sama kayak git ignore, dimana GitHub atau repository yang kita buat modul itu banyak. Nah, kita boleh masuk kontainer env. Yang ketiga, hasil build itu juga nggak usah masuk, yaitu si dist ini. Terus yang keempat, kita bisa masukin segala sesuatu yang berbau log dengan cara membayang apa yang docker ignore. Docker filenya udah ada, kita masuk ke terminal. Ini gue udah masuk di dalam proyekan React.js movie adik gue ya. Ini untuk min t spasi nama image-nya apa, terserah kalian. Biasanya kalau gue taruhlah di awal itu adalah apa ya namanya, parent foldernya, misalkan di sini React.js. Selanjutnya itu adalah proyekan apa yang kalian running di movie versinya 1. Pasti titiknya ini kita akan mencari docker file di sini, di directory yang kita sedang bahwa kita. Jadi kalau kita pakai cara yang paling sederhana dulu di awal, spek begitu penjelasan. Nah, kalau udah muncul seperti ini, itu artinya kita udah berhasil membuat image-nya untuk proyekan React.js adik gua di sini. Nah, cara cek image-nya di mana? Kalian bisa buka Docker image yang kalian punya, Docker desktop yang kalian punya, atau cek di terminal dengan Docker spasi images seperti ini, enter. Maka akan muncul langsung di sini React.js movie adik. Nah, gua nggak biasa pakai Docker desktop tampilan yang di sini sebenarnya, karena gue lebih banyak mainan Dockernya di server bukan di desktop PC Windows. Ini sengaja gue install desktop Dockernya buat tutorial YouTube aja guys ya. Kalau di asli tuh jarang banget pakai Docker desktop yang kayak macam beginian, karena semuanya tuh biasanya full terminal, termasuk mainan Kubernetes dan kawan-kawan kayak gitunya. Jarang banget mainan ada interface software kayak gitu-gitu. Tapi kalau kalian penasaran, di sini ada tab yang namanya images, kalian bisa klik. Ini muncul hal yang sama, React.js movie adik ada di sini. Ya, betul ya. Dan di terminal pun sama, React.js movie adik. Cuekin yang lain-lain ini adalah image gua yang lainnya yang kemarin bekas gua ngulik-ngulik lah, iseng-iseng kayak gitu ya untuk testing-testing. Kalau udah tahu ini image-nya kalian terbentuk ya dengan tag 1.0.0 untuk versinya dan image ID sekian, kita nyalakan proyekannya dengan cara apa? Nyalain project dari image yang udah terbentuk itu dengan cara docker spasi run spasi min d itu untuk jalan di balik layar ya, untuk di background supaya enggak spesifik langsung muncul di terminalnya, tapi terminalnya akan menghilangkan log-log tertentu supaya kalian bisa jalanin project React ini di balik layar terminal kalian atau di balik layar komputer kalian. Nggak akan kelihatan pokoknya. Nanti kita bisa masuk via docker exec atau via docker desktopnya langsung. Ya, kita ketikin docker run spasi min d spasi min p untuk listen portnya. Yang pertama adalah 3000 seperti ini. Nah, ini artinya apa? Sebelah kiri adalah nge-expose ke public, itu kita masukin port berapa. Sebelah kanan adalah port yang ada di dalam kontainer, itu portnya berapa. Tadi di dalam feed config-nya kita tentuin portnya di 3000. Terus kita expose keluar menjadi 3000 juga. Jadi intinya port yang di dalam kontainer itu kita expose ke public atau ke orang-orang supaya ngecek proyekan kita tuh di mana portnya di 3000 ini ya guys ya. Ini adalah yang di dalam kontainer. Spasi, nama image-nya apa? React.js/movie strip addict versi berapa? 1.0.0 kayak gini. Kita coba enter. Dan kalau muncul seperti ini, artinya kita bisa cek kontainer kita udah nyala atau belum dengan cara docker spasi ps enter. Kalian bisa lihat sini ada mana ya? Nah ini nih, React.js movie addict 100 10 detik lalu berjalan di port 3000. Sekarang kita buka browsernya. Nah ini kalau kalian cek di Docker Desktop pun udah masuk ke tab yang containers. Sini nih. Dengan nama Guizical Distra. Ya kayak gitu-gitu, ini namanya random. Kalian sebenarnya bisa set namanya langsung ketika kalian jalanin kontainernya, dockerannya. Cuman di sini kita nggak masukin flag untuk set name-nya, jadinya secara random dia akan tergenerate. Dan kita coba di localhost 3000 kita buka. Sekarang sudah muncul movies adik gue, ya. Cuman ada masalah pak. Di sini tidak tidak ada gambarnya. Sedangkan kalau kita nyalakan secara lokal itu API-nya nyala. Nih Yandev gue nyalain gini ya. Di port 3000. Oh sorry. Kita ubah dulu, bentar. 3001. Ini kita coba nyalain secara lokal dulu di 3001 nih guys nih. Ini muncul gambar. Ini 3001 adalah direct langsung di proyekannya pakai Yandev atau npm rundev kayak gitu. Dan yang 3000 ini di dalam kontainer ya guys ya. Tapi nggak muncul image-nya kayak ginian. Kita coba inspect aja, kita lihat di bagian konsol. Katanya Axios bla 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 config request failed. Jadi request API yang dilakukan adik gue itu nggak berfungsi. Ini kan ngambil dari internet ya kan, datanya dari API public yang tersedia, dia consume. Muncul kalau di direct lokal kita nyalain seperti biasanya, tapi nggak muncul kalau kita masukin ke Docker. Nah itu kan bisa jadi masalah. Sekarang kita fix hal tersebut. Cara fixnya adalah kita lihat ke bagian network, apa yang terjadi sebenarnya di sini, kenapa nggak ngeload. Dan lihat di sini apa sebenarnya yang terjadi. Di sini kalian bisa lihat nih, untuk endpoint undefined ini artinya kemungkinan env yang kita punya itu nggak terdeteksi. Di dalam proyekan adik gue itu ada env file di sini yang tidak terdeteksi di dalam Docker yang kita punya. Nah kalau kayak gitu kita coba Docker ignore-nya .env kita awasin, biarkanlah masuk .env-nya dan kita coba bikin versi baru sekaligus ya. Ini kan tadi kita masukin .env ke dalam Docker ignore, artinya env-nya nggak akan masuk. Kita build ulang image-nya dengan versi yang berikutnya dengan cara seperti yang kayak tadi. Oke, kita clear dulu, balikin lagi port dari React.js feed config-nya. Ini gua masukin ke 3000 lagi. Oke. Kita run ulang Docker build-nya sini dengan versi yang baru, yaitu versi 1.0.1 kayak gini. Kita enter, dia akan build ulang. Nah enaknya pakai Docker atau kita bikin proyekan jadi kontainer, itu kita bisa mainin versionnya supaya kita bisa tahu perubahan dan bisa nanti mainin rolling back ke versi-versi yang mana kayak gitu kurang lebih. Ini udah tergenerate lagi ya image-nya. Dan kalau kita masukin Docker spasi images, kita punya dua image di sini, versi 1.0.0 dan versi 1.0.1. Yang mana versi 1.0.1 seharusnya env itu udah masuk ke kontainer, dan kita coba nyalain langsung dengan cara Docker. Coba sebelum kita nyalain kita cek dulu apakah yang ini masih running atau enggak yang tadi di Docker PS. Nah ini masih running ya, berjalan. Kita matiin React.js movie addict 100 ini yang udah berjalan tadi, karena kita nggak akan pakai ini. Kita akan pakai yang baru yang versi 1.0.1. Ini takutnya bentrok portnya, dia jalan di 3000. Kita juga yang baru tuh masih jalan di port yang sama. Cara matiinnya adalah di sini perhatikan ada name yang random tadi itu, kita ketik aja sini Docker container spasi stop spasi namanya itu apa? Namanya itu ini tinggal di copy aja, masukin sini. Maka dia akan stop. Kalau kalian cek lagi Docker PS, ini udah nggak ada di sini ya. Untuk si React Movie versi 1.0 itu udah nggak ada. Jadi kita sekarang nyalain yang versi terbaru, Docker run min-p 3000. Nama image-nya adalah React.js /movie adik versi 1.0.1. Udah kayak gini, tinggal di enter. Cek lagi Docker PS running ya di versi 1.0.1, dan di Docker desktop pun kalian bisa lihat di bagian mana kontainer sini ini 1.0.1 ya, React.js Movie 1.0.1 udah jalan. Dan kita cek lagi ke browser, sekarang port 3000 udah nyala guys. Nah kayak gitu ya, udah aman ya, nggak lagi merah-merah, nggak lagi aneh-aneh di bagian konsol ataupun di bagian networknya. Semuanya sudah terload dan kita bisa klik ini ya, udah berfungsi dengan baik. Ini kita berjalan di atas kontainer yang kita bikin pakai Docker, dan kalian bisa ngoding lagi, lanjutin yang mana di mana. Ini akan running di balik layar secara otomatis. Kalau kalian restart PC-nya pun tinggal buka Docker engine-nya ini, terus nanti otomatis kalau kalian buka localhost 3000 maka akan langsung membuka ini gitu guys, tanpa harus kita start lagi dan kayak gitu-gitu. Seharusnya otomatis dia menyala, dan ini menyala di dalam Docker container ya guys. Jadi udah nggak lagi di dalam PC lokal kita yang nyalain pakai npm run dev di proyekannya langsung, tapi ini di sana. Ini gua nggak buka proyekannya, gua cuman ada Docker desktop doang di sini yang terbuka, dan kalian bisa cek lognya itu di dalam sini. Kalau di Docker desktop ya, di sini ada log-lognya. Terus kalian bisa inspect, bisa masuk ke terminalnya. Kalau kalian ls, di sini ada file-file yang kita udah setup dan masukin ke dalam kontainer. Jadi kontainer yang tadi kita masukin di Docker file ya, codingan Docker file tadi itu ada di sini /app. Yang mungkin tadi kalian bingung walkdir /app itu apa, itu adalah tempat proyekan kita berada di dalam kontainer, yaitu di dalam /app. Ini kita lagi ada di dalam kontainer kalau kalian buka Docker desktopnya. Ini versi development mode, right? Nah, bagaimana kalau versi production mode-nya? Ada dua cara lagi guys. Mau kalian pakai static file dengan reverse proxy Nginx, atau running based on Vite yang biasa ada di dalam package JSON yang dengan cara npm run preview kalau di Vite. Nah, sekarang gue bakalan kasih tunjuk gimana caranya kita bikin satu Docker file baru untuk versi production like-nya. Kenapa gue bilang production like? Karena sebenarnya kalau kalian cek di sini, ini kan ada preview di apa namanya nih, package JSON-nya ya untuk Vite. Itu ada npm run preview, yang mana kalau kita running secara lokal npm run preview-nya, dia sebenarnya akan menjalankan static file hasil build yang ada di dalam script sini kan. Itu bakalan jalan di localhost 4173 kayak gini, yang mana ini adalah dia merunning disk yang ada di sini. Oke. Jadi kalau misalkan gua coba ya build terlebih dahulu, yarn build. Oke, apa yang sudah tergenerate di bagian disk, yang mana di sini adalah hasil build dari React.js pakai Vite yang kita punya, itu dengan cara nyalainnya yarn preview kalau di lokal kita. Nah, kita bisa lakukan ini pun sama di bagian doc. Bentuknya previewnya x reverse. Ini namanya kayak gitu ya guys ya. X Docker file titik. Nah, titik preview misalnya kayak gini, atau titik stg boleh, yang artinya staging. Gini. Dan yang satu lagi yang ini kita rename jadi Docker file yang stg. Ini kita akan running preview. Kalau di dalam Docker file yang dev itu kan yang tadi ya, npm run dev. Sedangkan yang di Docker file stg kita bakal jalanin yang preview. Ini kita matiin dulu. Untuk base image-nya samain aja kayak yang sebelumnya, kita pakai Node versi 16 Alpine. Terus kita walkdir-nya samain juga, walkdir di /app. Terus kita copy sama kayak tadi guys, copy huruf gede semua biar enak. Copy package ini tadi sebenarnya berapa, port 3001 dan koma merunning apa-apa yang ada di dalam hard dulu di sini. Semuanya tercopy ke dalam cara npm run preview. Kita menentukan untuk server 3001. Jadi view ya, dengan cara kayak gini guys, docker spasi build spasi mint, ininya tetap sama kayak yang tadi, cuman isinya berapa gitu ya. Sama projectnya itu apa? Bukan React, staging di sini ya. Spasi min.stg spasi titik. Nah, minf ini supaya kita bisa langsung spesifik nentuin docker file mana yang mau kita eksekusi. Di sini karena kita running untuk staging mode yang mana menjalankan preview command di dalam Vite yang ada di dalam kontainer kita sini. Agak sedikit ribet ya guys ya. Jadi kita akan bikin image-nya itu sama kita ya guys ya, yang bernama docker file build, dan nanti kita coba tambahan .stg ini. Ketikkan docker docker image, banyak image. Tadi yang awal yang development mode itu ada React.js Movie Addict versi 1, React.js Movie Addict versi 101, dan sekarang kita punya image baru 00. Port berapa tadi? 3001. Terus strip add 3001 ini. Coba cek dulu docker ps. Jadi ada jalan ya. React.js Movie Addict 100 yang stg. Ini yang port 3000 yang dev. Lah, kayak nggak ada bedanya, Bang. Ini 3000 development, ini 3001 preview mode. Apa bedanya? Nah, perbedaannya salah satunya nih gue kasih tahu ya. Kalau kalian inspect di bagian yang di dalam source developer tools Chrome, ini gue pakai Chrome ya. Di bagian movies kalian bisa lihat walaupun ada yang kayak beginian, tapi di bagian src kalian bisa lihat sintaksnya secara langsung. Tuh, kelihatan ya. Semua sintaks untuk di bagian komponen lah, state lah, utilitiesnya, loader segala macam semua kelihatan ya guys ya. Nah, sedangkan untuk yang di port ke 3001 yang jalan di preview mode-nya Fit yang seolah-olah seperti production ready, yang mana sebenarnya nggak terlalu production ready juga. Kalau kalian inspect sini, pergi ke bagian source, itu udah nggak bisa lihat lagi source code-nya karena sudah berubah semuanya ya menjadi kayak macam begini. Perbedaannya pokoknya kelihatan dah bedanya ya. Kalau seluruh sintaks tuh sederhana dan menggambarkan gimana kurang lebih performance-nya di device desktop kalau kita buka. Ini untuk port 3000 terlebih dahulu ya. Gua masuk ke Lighthouse DevTools-nya Chrome. Kita coba analyze dan kita lihat nanti skornya. Kita bandingkan dengan yang running via preview mode di Fit. Ya, kurang lebih kayak gitu. Kalau kayak gimana? Kurang lebih kayak gini. Sekarang kita coba, kita akan jalankan Lighthouse lain yang Nah, kalian bisa bandingin ya. Di sini untuk yang 3001 dia 98 performance-nya, untuk yang 3000 yaitu development mode performance-nya 76. Jadi terserah kalian it's okay, terserah kalian. Kurang lebih kayak gini. Walaupun ini tidak menentukan hasil secara menyeluruh dan hasil pasti, tapi ini sebagai acuan review. Pasti lebihnya dia perbagusnya yang mana, Bang? Terserah kalian. Mau yang versi dev dijalanin, nggak apa-apa, terserah. Mau dosa dan cek membuat kedua docker file yang udah kita siapin gitu ya guys ya. Nah, kedepannya
Docker. What Docker is and why it's so popular. This can also happen if the configuration settings run these dependencies inside an isolated environment called a container. And this is the beauty of Docker. This isolated environment allows multiple applications use different versions of some software side by side. So one application may use Node from project, several virtual machines on a real physical machine. For example, so with a hypervisor, we can manage virtual machines divided between different kernel of the host. What's a kernel? Of the underlying both Linux and version I'm using in this course. So here I'm using Docker. So to get Docker for desktop for Linux, we only have the Docker engine, but we version from Docker Hub. But before doing this, I highly encourage you to go through system requirements and make sure your computer satisfies these requirements. Otherwise, you might encounter weird issues. So if you don't see this, you need to wait a little while until Docker. How? We just add a Docker file to it. Or how it's built, we take that application and Dockerize it, which means we make a small change so that it can be run by Docker. How? We just add a Docker file to it. A Docker file is a plain text file that includes instructions that Docker uses to package up this application into an image. This image contains everything our application needs to run. Everything. Typically, a cut-down operating system, a runtime environment like Node or Python. It also contains application files, third-party libraries, environment variables, and so on. So we create a Docker file and give it to Docker for packaging our application into an image. Once we have an image, we tell Docker to start a container using that image. So a container, as I told you, is just a process. But it's a special kind of process because it has its own file system which is provided by the image. So our application gets loaded inside a container or a process, and this is how we run our application locally on our development machine. So instead of directly launching the application and running it inside a typical process, we tell Docker to run it inside a container, an isolated environment. Now here's the beauty of Docker. Once we have this image, we can push it to a Docker registry like Docker Hub. Docker Hub to Docker is like GitHub to Git. It's a storage for Docker images that anyone can use. So once our application image is on Docker Hub, then we can put it on any machines running Docker. This machine has the same image we have on our development machine, which contains a specific version of our application with everything it needs. So we can start our application the same way we started it on our development machine. We just tell Docker to start a container using this image. So with Docker, we no longer need to maintain long, complex release documents that have to be precisely followed. All the instructions for building an image of an application are written in a Docker file. With that, we can package up our application into an image and run it virtually. In this lesson, because I just want you to see the big called, open it in Visual Studio Code. Any editor that you prefer, you don't even need to in lowercase dot message on the build application don't know, so we get the output. So here are the instructions for deploying this program. We need to start with an operating system. Then we need to install Node, which is an execution environment for JavaScript code. Next, we need to copy our application files. And finally, we need to run node app.js. So we have to follow 4 steps just for a simple program. What if we were working with a really complex application? You would end up with a complex release document that had to be precisely followed. Now this is where Docker comes to the rescue. We can write these instructions inside a Docker file and let Docker package up our application. So back to VS Code, we're going to add another file to this project called Docker file. So capital D and all the other letters are lowercase, and this file doesn't have any extensions. Okay. Now VS Code is asking if you want to install the recommended. So typically we start from a base image. This base image has a bunch of files. We're going to take those files and add additional files to it. This is kind of like inheritance in programming, okay? So what is the base image? Well, we can start from a Linux image and then install Node on top of it, or we can start from a Node image. This image is already built on top of Linux. Now, how do I know these names? Well, these images are officially published on Docker Hub. So if you go to hub.docker.com and search for Node, you can see the official Node image here. So Docker Hub is a registry for Docker images. Now back to our Docker file. So we start from a Node image. Now if you look at Docker Hub, you will see that there are multiple Node images. These Node images are built on top of different distributions of Linux. So Linux has different distributions or different flavors used for different purposes. Now here we can specify a tag using a colon to specify which Linux distribution we want to use. For this demo, I'm going to use Alpine, which is a very small Linux distribution. So the size of the image that we're going to download and build on top of is going to be very small, okay? So we start from that image. Then we need to copy our application or program files. For that, we use the copy instruction or copy command. We're going to copy all the files in the current directory into the app directory into that image. So that image has a file system, and in that file system, we're going to create a directory called app, okay? Now finally, we're going to use the command instruction to execute a command. What command should we execute here? Node app that fixes it with the directory name. Alternatively, here we could set the current working directory workdir to /app, and then we don't need to prefix this with the directory name. So when we use this instruction, all the following instructions assume that we're currently inside the app directory, okay? So these instructions clearly document our deployment process. Now we go to the terminal and tell Docker to package up our application. So we say Docker build terminal, clearly document our deployment process. Now we go to instructions, clearly document our deployment process. Now, we go to the terminal and tell Docker to package up our application. So we say Docker build. We need to give our image a tag to identify it. So -t. Here we specify a name like hello Docker. And then we need to specify where Docker can find a Docker file. So we're currently inside hello Docker directory, and our Docker file is right here. So we use a period to reference the current directory. Let's go with that. Now you might be expecting an image file inside the current directory. But back in VS Code, look, there is nothing here. Because the image is not stored here. And in fact, an image is not a single file. How Docker stores this image is very complex, and we don't have to worry about it. So back to the terminal. To see all the images on this computer, we type Docker images or Docker image ls, which is short for list. So take a look. On this machine, we have a repository called hello Docker. In this repository, we have an image with this tag, latest. So Docker added this by default. We'll talk about this later in the course, but basically we use these tags for versioning our images. So each image can contain a different version of our application, okay? Now, each image also has a unique identifier. Here we can see when the image was created and the size of this image. So because we used Node from Linux Alpine, we ended up with 112 megabytes of data in this image. So this image contains Alpine Linux, Node, and our application files. And the total size is 112 megabytes. Now if we use a different Node image that was based on a different distribution of Linux, we would end up with a larger image. And then when deploying that image, we would have to transfer that image from one computer to another. So that's why we use Node Alpine, because this is a very small image, okay? So we have built this image. Now we can run this image on any computer running Docker. So on this machine, which is my development machine, I can say Docker run and then type the image name, hello Docker, and it doesn't matter which directory I'm in because this image contains all the files for running our application. Now look, we see the message on the terminal. Now I can go ahead and publish this image to Docker Hub so anyone can use this image. Then I can go on another machine like a test or a production machine. and pull and run this image. In fact, I've done this before recording this video. So back to Docker Hub. Look, I have this repository code with mosh / hello docker. Now we can take this image and run it on any computers. Let me show you something really cool. So let's search for play with Docker. Let's go to this page and log in. Here we need to sign in with our Docker ID. Anyone can create this ID on docker.com. So let's go ahead and start a lab. Over here, we can start a new virtual machine. So let's add a new instance. Now, this virtual machine is a blank machine. It only has an operating system, which is Linux, and Docker. So in this terminal window, if we type node, look, node command not found. So node is not installed here. But because we have Docker, we can pull and run the image that I published on Docker Hub. So let me maximize this window by pressing Alt and Enter. First, let's run Docker version. So on this machine, we're running Docker version 20.10.0. So to pull and run my program, first we type docker pull code with mosh / hello-docker. All right, Docker downloaded this image. We can verify it by typing docker. What command should we run here? Docker images or image ls. So on this machine, we have this repository code with mosh / hello docker, and this repository contains a single image with this tag latest. So now we can run this application exactly the same way we ran it on my development machine. So from any directory, we can type docker run code with mosh / hello-docker. And here's the message. Beautiful. Of course, I had to cut this down in editing. It took a little while to start this application on this very slow virtual machine, but you got the point. So we can take any application and Dockerize it by adding a Docker file to it. This Docker file contains instructions for packaging an application into an image. Once we have an image, we can run it virtually anywhere, on any machine with Docker. Hey guys, Mosh Coding School competition to receive a 30-day money-back find down below. Linux. What if you're a Windows user? Well, you still need to is the Linux command line. But why Linux? What if you're a Windows user? Well, you still need to know a bit of Linux for a number of reasons. For starters, Docker has its foundations built on top of basic Linux concepts. So if you want to be productive and troubleshoot issues easily based on Linux commands, learning Linux is like learning English. I think everybody should know some English these days. You don't need to speak it or write a book in it, but you need to understand it. So unless you're a power Linux user, do not skip this section. It's going to be super easy and extremely useful. So let's jump in and get started. Each of these distributions is made to fit. I want you to start taking notes. So watch this video, take some notes, and then after the video, repeat the steps I have shown you, okay? So we go to hub.docker.com and search for Ubuntu. Over here, you can see the official Ubuntu image that's been downloaded more than 10 million times. Let's have a quick look here. So for each image, you can see the command to pull that image onto your machine. Now in this lesson, I'm not going to use the pull command. I'm going to show you a shortcut. So here in the terminal, instead of running docker full Ubuntu, I'm going to run docker run Ubuntu. Now, if we have this image locally, Docker is going to start a container with this image. Otherwise, it's going to pull this image behind the scene and then start a container. So, take a look. See, Docker is unable to find this image locally, and now it's pulling it from Docker Hub. Now, what happened? Well, Docker started a container, but because we didn't interact with this container, the container stopped. Let me prove this to you. So if you run docker ps, we can see the list of running processes or running containers. Look, we don't have any containers running here, but if you type docker ps-a for all, we can see the stopped containers as well. Let me increase the size of this window so you can see it clearly. Good. So we have two stopped containers. The first one is using the Ubuntu image. This is the one that we just started. And the second one is Hello Docker, which we started earlier in the course. So to start a container and interact with it, we have to type docker run -it, that is short for interact. Active. We're going to start a container in the interactive mode. And in this container, we're going to load the Ubuntu image, which we have locally. Good. Now, what we have here is called the shell. A shell is a program that takes our commands, and now interactive, we have to type docker started earlier in the course. So to start a container and interact with it, we have to type docker run -it, that is short for interactive. We're going to start a container in the interactive mode. And in this container, we're going to load the Ubuntu image, which we have locally. Good. Now, what we have here is called the shell. A shell is a program that takes our commands and passes them to the operating system for execution. Okay. Now, what we have here is called the shell prompt. Let me break it down for you so it doesn't look mysterious. The first part, root, represents the currently logged in user. So by default, I'm logged in as the root user, which has the highest privileges. Then after the @ sign, we have the name of the machine. So this container has this ID, which is automatically generated by Docker. And in this case, it's like the name of a machine. Okay. Then after the colon, you can see /. That represents where we are in the file system. A / represents the root directory. That is the highest directory in the file system. We'll talk about that soon. Then we have a £, and this means I have the highest privileges because I've logged in as the root user. If I logged in as a normal user, instead of a £, we would see a $sign. Okay. So in this shell, we can execute a bunch of commands. For example, we can say echo hello, and this prints hello on the terminal. We can also say who am I? This shows the current user. So these commands that we're running here, this shell program that I told you about, takes these commands and passes them to the kernel for execution. Now let me show you /bin/ we have a pro shell. Okay. Now one thing you probably noticed is that in Linux we use a / to separate files. The other case, but in Windows we use a \. So that's one of the first differences. The other difference is that Linux is a case-sensitive operating system. Bash tells us echo to pretty much case letters. Now one last thing for this lesson. Using the up, pretty useful short. Using the to know because you don't want to type these commands manually all the time. Okay. Also, using the history command, we can see for this lesson. Using the up and down arrows, we can go through the commands we have executed so far. So this is a pretty useful shortcut you need to know because you don't want to type these commands manually all the time. Okay. Also, using the history command, we can see all the commands we have executed lately. So take a look. So earlier we used typing. This is go through your notes and execute the commands I have shown you in this video. Execute the commands I have shown you in this video. These days, most operating systems and development platforms come with a package manager. You've probably worked with tools like npm, yarn, pip, and so on. Here in Ubuntu, we also have a package manager called apt, which is short for Advanced Package Tool. So let's execute this command. Look, this command has a bunch of subcommands. So that technically a lot in online tutorial. Let's say we want to install a package called Nano. Nano, because this Ubuntu image we are running, if we type apt install Nano happening. Well, here in Linux, we have a package database, and this database might contain hundreds of packages, but not all these packages are installed. So if you want to see all the packages in this database, we type apt list. Look, these are all the packages. Now, in front of these packages, you can see some of them are installed. Install Nano. This command looks at the package database. Okay. Update command is going to apt. As you can see, list. Most of these packages are not installed because we don't have installed in front of them. So now we can run apt install Nano to take away. Before installing a package, you should always run apt update to update your package database, and then you can install a package like Nano. Now we'll talk about Nano later in this section, but before going forward, let's make sure that this package is installed properly. So let me resize the window. Great. Next. We're back. So we have installed Nano. Now let's say we want to remove it. So information, access point, organized in a tree, and so on. In other directories, for example, we have bin, which includes binaries or programs. We have boot, which includes all the files related to booting. Then we have dev. The first time I saw this, I thought this is short for development. It's not. It's short for devices. So in Linux, everything is a file, including devices, directories, network sockets, pipes, and so on. So the files that are needed to access devices are stored in this directory. Then we have etc. There are different opinions what is this short for, but one common opinion is this is short for editable text configuration. So this is where we have configuration files. We also have home. This is where home directory is directory here. We also have root, which is the home directory of the root used, keeping library files like software library updated frequently, which includes files that represent this devices. Even here, I'm going to show you we can navigate the for. So here we type ls, which is short for list. You can see pwd, which is short for print working directory. Present for list, binary files, which is and one. Okay, we are. So in this root directory, 3 directories. So I'll see you in the next lesson. Great. Now how to edit file. For exiting is concatenate or but once again,